Okay, let's get started. First of all, you have to go to www.microbit.org and click Let's Code at the top of the website. Then click Let's Code below the JavaScript blocks editor and you can get access to the blocks interface. Now you can create your first program for the Microbit by using JavaScript blocks editor. This is the blocks interface. There are four main parts. The first part will be the simulator window, the order blocks, the coding area, and download and save. When you start your program, you don't need a Microbit to test your code. Once you finish your script, you can click the Run button and the simulator window to the right of the code view will display the result of your code. You can click the buttons to emulate actions on a physical device. So when you are coding in the coding area, the result of the coding will display to the simulator window. Next is the order blocks. They provide basic functional commands of the Microbit. Order blocks are grouped under different code drawers by their type of function, such as basic, input, and loops. The Microbit can do many things through programming. You can drag or drop the blocks to the coding area and they will snap together to build programs which run your Microbit. It's a great introduction of programming for beginners. So when you run the program, when you enter to the coding area, there are two preset blocks. Do you know what their functions are? For the onStart blocks, when the Microbit runs, this part of code automatically runs once. For the forever block, when the Microbit runs, this part of code keeps running at the background. When you finish your script, you can download or save it. Click Download, your script is converted into a hex file and saved on your computer or the Microbit. Besides, you can enter the name of your project and click Save to save the file on your computer for further modification. So next part, we will start coding together. I will be 8. We can also apply the example to Microbit. Actually, the Microbit itself is considered as a hardware. In order to make use of the hardware, we need to write a code that tells what the hardware is doing and what combination of commands is used in order. That is the computational thinking. We now write the code for the above situation and input the if-then-else conditional loop for the process. So if the sensor sensed the temperature is over 25 degrees Celsius, such as 26, then the result will be the lights switched on. If the temperature sensor record the temperature is below 25, such as 24 degrees Celsius, the result is the LED displayed will be switched off.